understand what is a company doing in the area of machine learning and artificial intelligence, or how much value could be, let's say, attached to their function, right? All those kind of a thing. So attached to this area in various capacities. And I have been with Collabora working whenever they request, I come for trainings. That's the only place where I take some trainings and all those things. So happy to meet all of you. See you all coming here and that's a pretty large number that I see. So thank you all for taking out time, coming and meeting here, right? So I hope all of you are like, so what I understand is that because this is a large gathering which is there, so instead of discussing a topic, a single topic, and that too deeply, what I've decided is that there should be something for everybody. There would be people who would be just trying to start their career, and there would be participants who will be somewhere in the middle of their career, right? Who will be like manager sort of things, or senior managers also. So I have tried to include something for everybody. So this talk, I'll do it for 1.5 hours, and because this is a large number, so I leave the last half an hour for your question and answer. So you can ask me specific questions, right? And I'll be happy to answer them. Okay. And just one thing before like I start, my throat is not good, so at times you'll see that I'm trying to clean my throat. I'm sorry about it. It may sound a bit odd, but this is one problem, right? So the topic for today is like artificial intelligence revolutionizing the businesses, right? So that's what we are discussing today. There is no doubt, I mean, this is a technology which is revolutionizing not only business, personal lives, and almost everything, right? It's revolutionizing everything. There is no doubt about it. And many people are, a lot of talent is being attracted to this area these days, but there is a problem. People actually don't know what it comprises of, right? Partially, they know that this is what it is. If you ask people, they'll say, okay, this is about deep learning. Some people will say it is about neural networks. Somebody might talk about some complicated jargons and all those things. So all those things are correct. But what we'll try to do today is we'll try to look at this area holistically. What does it comprise of, right? And also remember, this area is growing every day. So that means the older paradigms, the older theories is still there, and the newer theories are continuing to evolve. So that means people like you who are coming and joining this area, there is a challenge because there are new platforms coming. There's a new knowledge that you have to absorb. The old thing is not going out. That is still there. So that means as you are joining late in this area, then the level of, let's say, the level of what I'll say, the kind of let's say efforts that you'll have to put would be very, very high, right? So the agenda for today roughly would be something like this. We'll define, because again and again we'll use data, statistics, ML, AI. So we'll try to define them. Why we'll try to define them? So that we understand how they are applied, their application, what will be required to get into this area. So it's always good to fix some kind of a definition, right? So we'll define them. We'll discuss some use cases, right? And these are real life use cases where like I have used them on my own. So I'm discussing only those use cases which I have been a part of, right? I've been deeply involved. Only those use cases I'm going to discuss. And then we'll discuss the current trends, what's happening in AI. What does it take to learn AI and ML? These are for people who are trying to get into this area. So what do you require? How do you get into this area? What kind of trainings and all that things that we'll discuss. For managers, the question is always, how do you manage this AI and ML talent, infra? How do you ensure that you get a business advantage out of it? I mean, just having some function for the sake of having it doesn't make sense. So what are the challenges? What are the advantages that we get out of this, right? So this is roughly what we are going to cover in this 1.5 hours, right? So let's get started. So I mean, it all starts, all of you would have seen it, I'm sure, in some or the other form. This is known as the data information ladder, right? So if you look at data information ladder, what we see here is that the basic thing is, the base thing is here. This is data, right? So this data was in earlier, like 20 years back, businesses in general did not have any systems to collect data, right? The system of relational databases and databases in general was also not very advanced. Slowly, the concept of databases came into place. So what started happening is that the business started at least securing, keeping data. This was the first step. Now what happened is suddenly when data was there, and you see people who say that we have tons of data, right? You generally listen to this phrase. Now what happened is once data was there, then people thought, why not convert it into some information, right? Or when you say convert into information, it will mean that we try to understand some kind of relationships from this data, right? So if you want to move from here to here, if you want to, like, let's say, understand these relations here, then you need some kind of processing here, right? And that's not a normal processing that is there. So then we got something known as machine learning, or you can call it statistical modeling. So statistical modeling came because business or human beings in general wanted to process data and get to some information, right? uh, a smaller cousin of ML would be something known as BI, right? Business intelligence. So business intelligence systems are systems which are more prone, or which can do simple tasks, or which can do very powerful slicing and dicing, and can show you things in a very visual manner. Examples could be Tableau, Spotfire, many of them there, right? Or or if you would have heard packages like ggplot2, rshiny, okay? So all those things. So that is the business intelligence part of it, more related to powerful slicing and dicing, and then making visual reports out of it, right? So they're making dashboards, reports, all these things out of it. But ML is like when you use statistical techniques, when you use some algorithms, if I can say, and then you try to understand relations. That's machine learning. So this phase also has been covered. If you look at 80s and 90s, so the world was working on this ML side heavily, and a lot of developments happened. Since 1970 only, this area, people were working very heavily in US. Though India, we did not see much of it. India started working on it in the mid 2000s only, but if you look at US, they are already started working. Now, this, if you look at this from information, then people saw that, okay, they are fairly doing well in terms of information. A lot of information is available, and that information was useful to some people, and that information was not useful to some people, right? From a machine learning perspective, data science perspective, these people were saying we have done a good job, but the business side was not very convinced about that, right? They say, okay, you have done something, but what do we do about it, right? So then the question was, can we take it further? Can we take that information to something like knowledge, right? And this is our AI paradigm. This is what is happening here. So the entire human or the mankind is trying to move from information to knowledge, right? Knowledge is something which is a very human quality, right? We understand. If you look at it here, knowledge means know what, why, and these are very human. And then take some action, know how, and all those things, develop some competence out of it, and probably from a business perspective, it can lead to some competitiveness, right? So this is a very human kind of quality, right? Understand how to take action, what action to take, what would be the right action, what would be the wrong action, understanding all those things, right? So then then what started is that we started on this journey, which is known as AI. I hope my screen and is visible to everybody, and I'm audible to everybody, right? So this is the journey which is started, which is known as the AI phase. So we are in this phase right now. Now you ask me, there is one more thing which is available, from knowledge to wisdom. Now wisdom is something not every human being has, right? You require to spend a lot of time. You need to have a lot of experiences. You need to understand the principles behind, right? Then only you are said to be possessing something known as wisdom. So definitely some sort of work has started here. So the later stage things after 5 years from now, the kind of systems that you will see would be bridging this gap between knowledge and wisdom. And wisdom is the ultimate form, of human development, right? So then that means I'll reserve questions at the end. So because otherwise what will happen is delivering this thing would be very difficult in 1.5 hours. So I'll request that please ask, I'm ready to answer your questions, but I'll answer it in the end, right? So that I'll take up as many questions as you want in the end. I'll stop at sharp at 12:30. Okay. So this movement that happens from here to here, this is what the new AI systems would be, right? These would be the new AI systems that we are going to get. Now you can understand, all of you are young, who are in your early 20s or late 20s, whatever, and trying to get into this area. For me, it was good. I entered at this stage, right? I entered at this stage. Okay, this area is still there, right? And I learned this recently, around 3 years back. I learned this area. And when you enter actually 2 years, 3 years down the line, the world would be here. Now, can you understand your challenge? This is what I was saying. This whole thing, this whole line has to be learned by you. Whereas the advantage with me was I learned this, then being in the job, being on the job, I learned this, and I'll probably in the next 2-3 years I'll learn this, right? But my learning curve would be in effect, right? For you, you will be new, and you'll have to learn this entire line. Okay, so this understanding is important, and why I'm showing this or why I'm spending time on this is a group framework to look at companies, and you can understand by looking at companies which area is it operating. Is still struggling with the idea of data? There would be companies which are still struggling with the idea of data, that's all. And somehow if they make this happen, then BI is the only solution that they require, right? So there are companies which only require a BI solution, that's all. So if you know Spotfire, ggplot, and all those kind of stuff, that's all, right? But if it is a company which has like tasted some, I mean, data and all those things, it has been putting securely for a long time, and it has a lot of data, and now it requires to impact its operations, customers, anything. So then that kind of a company will require a ML kind of a thing, right? And if the company is still advanced in its journey and it's already done ML for a few years, then it will definitely try to move to AI. So when you move from ML to AI, you are trying to better your processes. It's not a new approach altogether. In 100% cases, you cannot say that it's a new approach. So I'll not say ML and AI are completely new things, right? And that we'll discuss in some later slides also. Okay, so this is how you can understand about companies also, where they stand, how they stand, or what kind of a effort will they require, right? So here you can understand it very easily. Okay, so let's move forward. And so data, like how do we define data? That's very important. This is the most important thing in our entire journey, isn't it? It's the starting point. So garbage in, garbage out, you have heard. So data is like very quick definition, facts and statistics. See, this word comes, right? So generally people ask like, what is the role of statistics and all those things? So facts and statistics. So facts is a different thing and statistics is a different thing. So facts and statistics collected together for reference or analysis. Some people, instead of statistics, if they have a DB kind of a background, they loosely call this thing as metadata also, right? So this is known as metadata also. Some people call it metadata also, right? Data about data, right? So facts and statistics collected together for reference or analysis. There are some DBs which not only collect data, but also collect the statistics portion of it separately for you to look at, right, automatically. The other definition could be the quantities, characters, or symbols on which operations are performed by a computer, right? So operations are performed by a computer, which may be stored and transmitted in the form of electrical signals. So here, if you look at it, this, if you adhere to this definition, this clearly says that data is something that should be handled by machines, right? So computer will is a generic word, but it can mean databases, all sorts of databases. Okay, so data is very closely related to databases. Or the other definition, the third could be things known or assumed as facts, making the basis of reasoning and calculation. This one I think is a very good definition, because things which are already known, or if they are not known, you make some intelligent guesses, right? Assume. So you assume that as facts, right? They may not be coming from a source which is original, but may have come from some other source. But you assume it to be, let's say, correct. Assume it to be a fact, right? And then you make, and that then becomes a basis for reasoning or simple calculations, right? You may do simple calculations, like example in financial analysis, you just do simple calculations. There is no intelligence out there, right? There is a fixed method in which calculation should be done, and that's it, right? On the other side, when you do reasoning, there is no fixed method out there. You'll have to search for a method and then work upon it, right? So once you get data in your hands, when you lay your data, when you lay your hands on the data, then there are different options that are open to you, right? Now this data thing, when you look at data, though this is a very simple word, you'll see that data can be classified, data can be understood and divided into different parts. If you look at it, right, data could be structured data versus unstructured data. So as a data scientist, whenever you lay your hands on data, these are the questions you'll ask, right? So whoever is the owner of the data, generally the owner of the data would be a DBA team. So you'll ask, is it structured data or is it unstructured data? What does structured data mean? Structured data means any data which can be put in an Excel file. I'm taking Excel file as a reference because everybody knows it. It's a flat file. So anything that can be put in the form of columns and rows is structured data. Now, example, if there is name of people, one of the variable or one of the columns, let's say contains the name of people, then is it structured data? Yes, it is a structured data, though that may be a textual entry inside that form, isn't it? Because name of people would be names, right? Characters. So that's structured data. Versus unstructured data. What is unstructured data? Unstructured data is something like somebody gives you PDFs, right? So somebody says that these are PDFs and these are, let's say, customer contracts. There are many services where people require customer contracts. Example, when you get a mutual fund, insurances, there is a contract, right? So all those things require some kind of, when you buy a vehicle, there is a contract there. Anything legal will have a contract. So let's say some company has a lot of customer contracts and they have been accumulating this for over, let's say, 10 years, right? So when like this this entire data has been accumulated for, let's say, 10 years, then what happens is that we need to take out some meanings from these PDFs, right? So whatever you do to take out meanings or information from these PDFs, this is known as unstructured. Or another example could be you download some data from the web. Let's say there are customer feedbacks which are available on the web. You scrape the web and you get that data, and you try to find out something known as, let's say, sentiments, emotions, anything, right? Or in general, there could be suggestions also. You are trying to find out some suggestions. Then that is all unstructured data. Lot of product development these days happens not from prototyping. Earlier, what used to happen is companies used to develop a new product and they used to launch it in the market and try to see what kind of reaction is coming. And based on that, they'll either modify or do something. Nowadays, what they do is before launching, they launch the idea and people interact there, give ideas and all those things. And that saves a lot of time for them, provided you are able to analyze that data precisely and properly, right? So structured versus unstructured data can be classified as structured data versus unstructured data. Structured data is easy to handle. Unstructured data is very, very difficult. If it is structured data, and there are chances that machine learning, only application of machine learning would do the job for you. But if it is unstructured data, chances are that you will have to get into this area of artificial intelligence, right? So dealing with unstructured data is a difficulty. Now, data can be classified as cross-sectional versus a time series data also. What is a cross-sectional data? A cross-sectional data is a data that you get in at one time, right? So that may be a huge table that you get. There may be 1,000 variables that you have, and there may be 10 million rows, but you get it at one time. And time is not important there. Though the cross-sectional data may have been, let's say, collected over a period of 5 years, 10 years, that's fine. But cross-sectional data means that we are not interested in analyzing any time related things to it, right? We don't want to analyze any time properties there, okay? Whereas a time series data means where the time is of importance, right? Example, growth. If you want to calculate growth, the term growth itself has a time factor into it. So you need to understand growth, right? So cross-sectional versus time series. So cross-sectional data is again easy to handle, and time series data is very, very difficult to handle. There is no difference of machine learning and artificial intelligence here, but machine learning itself will have two category of algorithms, one which deal with cross-sectional kind of a data, and there is a separate category of algorithms that deal with time series data, right? So understanding data this way becomes very important. The second thing is your data could be continuous versus discrete. Continuous, what is a continuous data? If you have, let's say, if you look at the number line extends from minus infinite to plus infinite, right? So if your quantity can fall anywhere on the number line, it could be positive, negative, it could be a decimal, then it is supposed to be a continuous thing. And if for some reason it cannot utilize the entire number line, then it is known as discrete. Let me give you some example. Like example, weight could be 2.3 kg, right? Or it could be 1.2 kg. That is possible. Okay. And what is discrete? Discrete means, like example, number of cars crossing a particular any street or anything, right? So cars cannot be 2.3 cars crossing, right? Either they'll be 2 or they'll be 3. So only whole numbers are allowed, right? You don't allow let's say decimal numbers out there, right? So this is how data is classified. Now if you are thinking that, okay, we have spent some time on this lecturing business, what does this result into? This small idea has resulted into billions of dollars of business. You can see all this, right? Green Plum is one of the providers of databases. They have capability, they are very good at dealing with structured data, and recently they also provide some unstructured capabilities also, but they are not known for providing space for unstructured thing. Hive is synonymous to big data, isn't it? You have all heard this big data. I'm not dividing the data into big and small, because now everything is big data. Even if you don't have access to big data in your company, you can actually access the internet and pull a lot of other data and make your data really big, right? So and plus nobody knows how much big a data should be to call it a big data and how much small it should be to call a small data. But let me just mention one thing. If you have big data, even a person who's new can do analysis very easily. So the entire idea of let's say this big data is actually a great release. So if I get a big data, I'll always feel happy, because even if I don't have much experience in understanding algorithms, parameters, and all those things, I know just because of numbers, whatever I do would be very, very close to reality. The machine learning challenge always comes when you have small data. And this is like very, very strange when people say that, okay, big data has a difficulty. Big data only has a difficulty in terms of infrastructure. That's it. You require a special infrastructure. I agree. You require something like Hadoop to handle this. You require something which is written here, Apache Spark, to handle that. You require a Hive to handle that. You require these three things, I understand. So it is a special infrastructure that you require. I agree to that. But from a modeling perspective, big data, even a novice modeler can do very safe modeling on big data, if I can put it this way, right? So whatever you have heard outside, understand it this way. It's a challenge. Big data is a challenge from an infra perspective. That's fine. But that is also very sorted out. These infra is all open source now, is easily available, and a lot of talent is available, a lot of manpower is available who can do all this, right? So and that's like about data and big data. And you can see this Oracle is again a SQL kind of a database. MongoDB has come up, which is very, very good when it comes to unstructured data, right? MongoDB has specialized into unstructured data. So example, if you want to put your PDFs, text, lot of text you have and all those things, you can actually put it in MongoDB, and then you can retrieve it, or you can use whatever algorithms you want and it will do the job. So data alone, I didn't even reach to the ML place, right? So data needs to be stored, and it needs to be made available in a form in which machine learning can actually absorb it. This pipeline itself is a big business for the world. I've only just put few here, right? There are many, many more. If I try to put everything, I think it would would be a huge list out there. Okay, so this is a big idea. That's what I'm saying. Okay, so that's why I discussed that. Now moving on. So this itself, like understanding of data, is very, very important, right? Uh, Your questions, as I said, that I'll answer in the end, right? Because in the end, otherwise it will put a break on the flow of this. Then data types, if you look at it, then there are 4 kinds of data. Now, there we discuss data classifications. Now, this is data types like nominal, ordinal, interval, ratio. So what is nominal data? Like example, name of places, people, pin codes, gender, right? Like pin codes seem like numbers, isn't it? You see them like numbers, but they are actually not numbers, isn't it? So that kind of a data is known as a nominal data, right? It seems like a number, but actually not like a number, right? Gender could be like male, female, name of places, people. These are all nominal data, right? This is known as nominal data. They're just labels, right? The second type of data is ordinal. Ordinal is nominal data only, but what happens is there is the order into it. Example, when you capture, like example, income, when you say high, medium, low, right? We know high is higher than medium and medium is higher than low. We know that very well, but we actually don't know what is the exact difference between high and medium and low. We don't know. Or example, ranks, when you have in the class 1 2 3, yeah, you don't know the marks difference. We don't know the difference between the topper, the first ranker, and the second ranker may only be 1 mark, and the difference between the second ranker and the third ranker may actually be 5 marks, right? But we don't know that, right? But there is an order. Definitely the order is very important. Also remember that these 2 kinds of data, nominal and ordinal, combined together, this is known as categorical data also. This is known as categorical data, right? This is categorical data. Why I discuss this is, I come to that point also later. This is categorical data, right? Now, there is a third kind of a data which is not important to people who are working in machine learning. It's only important to people who are working in the area of, let's say, market research. So this kind of a data, machine learning guys, I mean, for them, it doesn't exist. But people who work in the area of market research, they definitely say that this area, this kind of data is there. So there is a interval data. So example, this generally from survey kinds of data. So all of you would have filled some kind of a survey form either in a restaurant or some other service or product that you would have taken. You will see there are 5 smileys that are there. You say highly disappointed, then the second one is disappointed, third one is I do not know, I'm not sure, the fourth one is that I'm satisfied, and the fourth one is I'm very, very satisfied, right? So now, so what is assumed is that the data is divided into equal intervals, right? So you have to divide the data into equal intervals, and every interval is equal. So interval data means this, but generally, as I said, this is not useful in machine learning, so I'll not spend too much time. The last one is the ratio data. The ratio data is, example is weight, age, and these are numbers. This is one, and the inferences that you can draw from here are arithmetic based. Example, if somebody is 50 kg and there is one more person who is 25 kg, you can easily say 2 things: that the person who is 50 kg is heavier by 25 kg because you subtracted 50 minus 25, it comes to 25. Or you can say that 50 divided by 25 is equal to 2. So the person who is weighing 50 kg is 2 times as heavy as the person who is 25 kg. Right? So ratio data, from a quality perspective, the nominal data is the best kind of a data, and your ratio data is the ratio data is the best kind of a data, and this is not such a good data, right? So that means that if you have nominal and ordinal data, then the machine learning algorithms that you need are of a very different type. They are very difficult. The kind of algorithms that you work with on ratio data are the easier algorithms. It's easier to work on ratio data because it's a high quality data. And to work on a categorical data, you require a lot of experience and expertise. So One more point that I'm adding. So when you go to a company and when you are hunting for jobs or you are trying to do a project, also understand what is the kind of data that it involves. If it is purely ratio data, you are very happy about it. You know you can do something about it, even if you are not experienced. But if it is categorical data, then believe me, you require a lot of experience. Generally, what happens in business is it's a mixed data. You'll have ratio data plus categorical data. Now that is the most difficult thing to do. When you have a mixed data, it's very, very difficult to handle, right? So that's one more challenge. So we have covered the data aspect here. In short, what I'm trying to say is that the idea of data, understanding data is very, very important. You have to understand data from many dimensions, right? From its type, classification, where is it stored, because if it is stored in a SQL thing, then you need to have some knowledge of SQL to extract it. If it is in Hive, then you need to have some information of Hive to extract data. So that means automatically before you do machine learning, you will require some knowledge of either SQL or HSQL, that is equivalent of SQL in Hadoop. So some SQL like thing, it is always good to pick up a SQL or SQL like kind of a programming language. It's very easy. SQL is very easy, but that is now required in modern day machine learning. That's a must. I mean, 5 years back, if I would have been taking this session, I would not have stressed upon this, but now I'm stressing definitely on that, right? So this is our first requirement, right? So first requirement comes knowing SQL. At least you may not be masters at it, but you should know something about it, because you'll have to fetch data as data scientists, and we need to know. So that's our first requirement. Now the second requirement is the statistics, because it is about data and all those things. So let's understand what the statistics is, and why am I saying that that may be required. Because how do you define statistics? You define statistics as saying the practice or science of collecting and analyzing numerical data in large quantities, especially for the purpose of inferring proportions in a whole from those in a representative sample. This is one definition. The other definition could be the which I like the most, and which and this is the definition which I think explains why we need to know some statistics. And this is the only science available that has the capacity to deal with uncertainty. What is business? Ultimately, if everything is guaranteed in business, you know everybody can do business, isn't it? Why don't people do business, or why don't people do many of the things? Because there is uncertainty involved. Uncertainty means risk, right? So certainty plus uncertainty is always equal to 1, isn't it? So if the uncertainty is 60%, then the certainty is only 40%, isn't it? So statistics, many people say that statistics is a branch of mathematics. I don't agree with that. It's a separate science. It deals with uncertainty, and it's the only science which deals with uncertainty. And that is the reason that if you look at insurance underwriting and anywhere wherever risk is involved, people do or require a lot of or financial modeling, equity modeling, or all those places statistics is religiously taught as a subject, right? Because that's the only science which helps you in dealing with uncertainty. When I say this, that means it will also have a role to play in our machine learning business also. So some part of the machine learning will not be clear to you if you do not know statistics. I say some part of it. I didn't say 100% will not be clear to it. Also, there are some algorithms which are heavily drawn from statistical modeling era, right? They are dependent on statistical modeling only. So if you do not know statistics, those algorithms you cannot understand. So the second knowledge area that we need to pick up. So the first one I told you, SQL or those related things, and I took that that entire data sermon with you. The second thing that we need to learn, we need to pick up, which is mandatory, is statistics, right? So this is mandatory to pick up. Now, we come to machine learning, right? This is also an area in itself. We need to define it. We need to understand what it is. How does it work, right? So I pick up two definitions. I'll not say that I brought the best definitions here. I brought only those definitions here which I think make sense to me. Now, some of you may actually stand up and say that, okay, there are better definitions and all these things. I agree to you, that can happen. that may be there, but that is there, right? So, and statistics also, like, because some question there asking inferences. So inference is an area where we have access to a small sample. We look at the sample and then we try to understand about a larger population. Example, see, you cannot go and meet every, let's say there is a company which wants to launch a new bike. Now it cannot go and meet everybody in India. Think of a country like India. It cannot go and meet everybody in India who is 18 years and above and ask him like what to do about the bike. But what it can do is it can draw a sample, intelligent sample, and talk to those people, and from that sample it can infer that what the larger or the bigger population may be requiring, right? So this is known as inference. So coming to machine learning. So machine learning is a subset of artificial intelligence. This is one view in the field of computer science. In the field of computer science, that often uses statistical techniques, right, to give computers the ability to learn. So statistical technique we have already covered, right? This portion we have covered, we have discussed. Now there is a new thing that is coming, which is learn. So it has a human capability. Humans have this thing to learn with data. We have covered this, right? So these two are integral portions of machine learning, statistical techniques and data. And the third thing that is getting introduced is the capability to learn, which is very, very human, right? Isn't it? That's why I said that artificial intelligence, that's why the name artificial intelligence, because it's a human-like quality. And humans, the biggest quality that God has granted to all of us is the capability to learn. We learn from good instances, we learn from bad instances, we learn from every experience, and we learn from the day we are born to the day we die, right? So we keep on learning from everything, right? So that's the best thing that we have. That's what intelligence is. So, and the other part is without being explicitly programmed, right? That is the important part. So that means you don't have to tell everything at a grassroots level, right? So there are few things readily available that you plug in. These are known as algorithms, right? So machine learning works through algorithms, right? That is, we need to understand. So the second definition, if you read, that's why I say multiple definitions are always good to look at, so that you understand completely what it is being said. So machine learning algorithm. So machine learning works through algorithms, right? They detect pattern, they learn how to make predictions. That's why you say predictive analytics, right? This is the word that is used. Recommendations, you do recommendations, isn't it? So people who read this also read this, people who bought this also bought this, that kind of a thing. By processing data, experiences, rather than by receiving explicit programming. So you don't write that how to do that. You just use the algorithm, and that will tell you that, okay, this is what the recommendation should be, right? Though I'm making it very simple. Some of you may say, who are experienced in this area, will say this is too simplified. Okay, but it's not very far away also. The algorithms also adapt in response to new data and experiences, right? Understand this. So they are learners. This is the learning capability, right? What does learning mean? When you keep on responding to new inputs, right? So as soon as you start getting new inputs, that's why you're intelligent, you learn and you respond, right? Example, many of you would have got this input now that machine learning or artificial intelligence is an upcoming area, is a great area, and in response to that you are trying to collect knowledge on that, and you are trying to see how to get into it. Depending, you are trying to get into the area, you are managers or whatever role that you are playing out there. Okay, so that happens, right? So let's move to the next thing. Now, generally, if you look at machine learning, it can be divided into three phases. One is descriptive. Descriptive, this portion is dealt by statistic. This is purely dealt by statistic. You don't require any machine learning out here. This is only statistic. So when you do descriptive analytics, this means you are only talking about using simple statistics. No algorithms, no machine learning is to be used, right? This is what it means. But as soon as you say that I'll do something known as predictive thing or a prescriptive modeling, or then your focus is on machine learning. Definitely these two will mean that your focus is on machine learning. Both of these things mean that your focus is on machine learning. So what does predictive mean? That you anticipate what will happen. So you answer questions like what is going to happen. So you take historical data and you try to predict the future, right? And when you're predicting the future, there is a big assumption out there, isn't it? And what is that assumption? That The future will follow past. The future is going to follow the past. By chance, if somebody guarantees you that the future is not going to follow the past by whatever, never a future follows the past 100%. But if somebody says this percentage is going to drop to 0, then your predictive analytics cannot be done, right? It's definitely not possible to do any kind of predictive analytics if somebody guarantees you that your past is not going to follow the future. The third one is the very advanced kind of machine learning application, which is known as prescriptive. Now, the prescriptive is what to do. Once I know the future, this is like this. Suppose I come to know that in future, I'll have some kind of illness. Now, what to do? Can I do something today so that I can prevent it from happening? Similarly, if the business knows that my sales is going to go down because there is a competitor which is going to come up, or the customer preference is going to move away or shift away from my product, can I do something today so that the future is the way I like it, right? So it's making a future the way I like it, right? So avoiding bad things and probably strengthening the good things, this is known as prescriptive analytics. So when you use your machine learning to do any of these things, then this is known as the prescriptive analytics, right? Okay, so three flavor: descriptive, predictive, and prescriptive. So machine learning happens in three things: descriptive, predictive, and prescriptive. So whenever you do predictive or prescriptive analytics, then only you focus on machine learning. Descriptive is generally done through only statistics. So now learning is something which is very, very important to this entire game. So there are three kinds of learning. Always remember that. So the first one is known as unsupervised. Examples would be, I'm giving some examples, like example clustering. When you say clustering is an algorithm that is used for unsupervised learning. Or in the modern era in artificial intelligence, some people say we are using encoders, right? Those encoders are used for unsupervised learning. We'll take one example so that we understand. Then there is something known as supervised learning, right? Supervised learning is something known as a example could be classification. Then the third type of learning, which is very, very relevant today, is reinforcement learning. And this is where the modern era of deep learning or artificial intelligence, as you call it, is very, very important, because it can be the older machine learning era. This was not possible to implement that easily. Now with coming of deep learning architectures, neural network architectures, better neural network architectures, this is possible. And what it means is that you learn from interaction with the environment. Isn't it very human-like that you know something, you go outside, and if you learn something new, you unlearn the older thing and you pick up the new thing, right? So the learning keeps on happening continuously. Wherein in unsupervised classification, the learning was happening only at one shot. That's it, right? One shot, the learning will happen. And if you want a new learning to happen, then what will you do? You will have to bring in more data or a different kind of a data. Then only the learning is going to change. Here, this recurrent or the reinforcement learning will keep on happening with new instances which are coming, right? It will happen automatically. To give you an example of unsupervised learning, example, there could be think of a telecom company. It has a lot of customers and it wants to roll out some programs for them, right? So what kind of a programs will you, and you've seen telecom companies, they give you like 249 rupees thing for 449 kind of a program and all this. So how do they do it? They take their customers and divide them into homogeneous groups, right? And those groups, when you divide them into the groups, you can understand what kind of quality or attributes those groups have, right? So once you understand that, you know what kind of a marketing program or product is going to suit them, right? So unsupervised, you do clustering, profiling for this, right? What is supervised learning? Supervised learning is where initially you have to act as a teacher, right, to the machine, and then the machine will learn like a student, right? So that means examples could be, let's say there is a company, there is a bank which is into this business of granting loans, right? So there will be a lot of data it will have available, right? The past data it will have. So based on that past data, it will know who are the people who returned the loans and who are the people who did not return, right? So this data can be fed to the machine, and one of the variable would be on the left hand side, you will have let's say 100 number of columns which will contain the data about the customer, and the 101st column will contain information whether the person returned the loan or did not return, right? So binary kind of a situation, returned or did not return. Now this data you feed to the machine, and you run something known as a classification algorithm. How many classification algorithms are there? There are 90 kinds of classification algorithms which are there. Generally people will know 8, 10 only, right? They have knowledge of 5, 6 algorithms only maximum out of those 90, right? So that is fed, and then what happens is that the machine will learn that in what cases actually these algorithms can be, let's say, these algorithms will work and will learn what is happening out there, right? So supervised learning will require labeled data. Labeled data means cases where you can tell the system that these are the cases where probably the loan was returned. These are the cases where the loan was not returned, right? So these kind of things, this kind of information has to be fed, and this is known as supervised learning, right? So for supervised learning, you need historical data which is tagged, which is labeled, any term you can use, right? Or that's known as training data because you're training the machine. Now you'll see that data is called as the new oil. You know what had oil done when oil was discovered? You know, it revolutionized the world the way like nothing before it had revolutionized. It changed the world the way nothing ever before changed it. In that sense, data and data science is a big movement. It's going to change the world in a similar way in which nothing in the past in the technology stack would have done that, right? So it's a big thing. It's going to change the world. There's no doubt about it. So that's why it's said to be the new oil. This is one. Also, at the same time, training data is the new oil. What is training data? So if you have trained data, right? Somebody is ready to give that trained data, then machines can learn through that. Because businesses don't share their data, they keep it very, very private. So if, let's say, I open a new lending business, then what is going to happen? The older lending data from the other companies I will not have. Now I can't straight away start machine learning. I'll have to wait. I'll have to wait for some loans to go bad, some loans to go good, and then only probably we can go ahead and do that, right? So there has been requests from 1 or 2 participants for speaking in Hindi. There is no problem, I can speak in Hindi, but the problem is here that we have a large number of participants and all of them may not be comfortable in Hindi, right? So though I can speak in Hindi, but just looking at the group, I'm not speaking because many of the participants will then start commenting that they are not able to follow it in Hindi, right? So please, you'll have to bear with that, and anything we can, and if you have any specific thing that you are not able to understand, for such people we can take another session where we can take it in Hindi, right? That I can do. So a separate session in Hindi I can take for those people, okay? So now, as I said, that the machine learning's, the entire business of machine learning is dependent on something known as algorithms. So what are algorithms? That's fine. I've used this word earlier also. So when you say what are algorithms? So algorithms you can think of as a big bunch of codes. These, right? Some codes written. Codes. Now they can be any programming language. They can be in a programming language known as Python. They can be in a programming language known as Java, right? All these are programming languages. You can read about it, right? So think about it that there are a lot of codes written, right? There are a lot of code, and those codes are not visible to you. You only use those, and there is some kind of API that is given. You just use that. So for you, it is a very small quarter line kind of a code that you fire, or if it is a visual kind of a thing, you just click on something and it works, right? But in the backdrop, this is a big page of code. You can imagine it this way. And that code you can divide into 3 blocks, right? I mean, you'll write codes and you'll have some target while you're writing codes, isn't it? I mean, you just don't start writing codes here and there, right? So the first portion of these long codes is known as the method block. The method block codes are written to explain to the machine what to do. So when you say clustering, then there is a method of doing clustering. So that method is written in those codes. The second block is optimization. The machine is dumb, isn't it? It doesn't know when to start and when to stop. You have to explicitly say that start or stop. Or if you want to make the machine stop, there are 2 methods. One, you tell it that do this thing for 1,000 times, let's say, do it 1,000 times. Machine can do it any number of times because the processing speed is phenomenal. So it can do it as many times as possible. Or you say that, okay, there is something known as error. An error is an indication of the improvement of the last result and how much has the current result improved over the last result. So if the improvement is not happening in subsequent steps, I mean, why to go forward? Just stop, right? So the first condition is you say do it 1,000 times and don't worry about how much improvement has happened. Stop and print the results to wherever, like to the screen or to any file that you want, right? Or it could be that you give it a target and you say this is the error and you need to keep on working till the time this error either minimizes or you find it, you can't minimize it, right? You suddenly you realize that no, it cannot be minimized further because it's a difficult problem, so you stop, right? So stopping conditions are to be given. This optimization block, now I'm introducing one more thing. The optimization block essentially comes from the operations research area. And that is why you will hear terms such as gradient descent, stochastic gradient descent, Adam optimizer. Now these terms for many of you may be sounding like Greek and Latin. Don't worry about it. The idea is not to tell you what optimization methods are or to make you run immediately to learn these methods. That's not the idea. I'm just telling you that this area comes from operations research. Okay, so there is mathematics is slowly getting in, isn't it? And operation research also, if you see, derives value from 2 other areas, that is calculus and the other one is matrix algebra. So machine learning by default has mathematical components into it, which are matrix algebra, operation research and calculus. These 3 are required. Now the question could be, can I get into the area of data science without knowing mathematics? To begin with, you can know, there is no problem. But as you spend 5 years, so there has to be a difference between a person who has 5 years experience, 10 years experience and 15 years experience. And this is what that difference is. Till 5 years, probably you are just firing your algorithm, that's it. You know what the algorithm does, but you can't get under the skin of that algorithm. You exactly don't know what mathematics is involved there, what process is involved there. You don't know that. But beyond 5 years, you should very well know that what is the process followed. If you are 10 years old, you should know the mathematics also of it, right? So you need not learn everything as you get inside it. That's not important. But you should know these are your long-term targets. You'll have to learn as you go along, right? There are 70% of the people that I have seen do not know anything about mathematics. And their problem is after 2 years, we do not know what to do with them because their further capability of learning just diminishes. They are just dependent on codes and they keep on telling, I've solved this problem, I've solved that problem. I get a lot of CVs day in and day out, 10 years experience, I've solved this problem and I build this and the business benefited. And when you go skin deep, then suddenly you realize that they do not know anything. Then you start doubting. When you do not know anything, how is it possible that the business benefited, right? So it must be either by luck, or the business people were really did not know anything. So whatever you gave them, they were happy about it, right? So those are the things. So what I'm trying to say is, to become a good data scientist, you have to pick up new knowledge areas. It's not a static thing. It's not like programming that you once learn it and then you keep on using it for 20 years. That will not work. I've spent 16 years in this area, and I still say that even if I've learned 1% of this area, I'll become a big man, right? I'll become a huge personality, I'll say, right? So after spending 16 years, I don't know even 1% of it, right? So this is the enormity of this area. The third block is the validation block. Now, this validation block is something where we test. We test that whatever result, we formally test the results that we have received, are they correct, right? So we do a hypothesis testing around that whatever we have received, is that the right result? Is it that we have received it by luck, or is it actually a correct result, right? So that's what we try to discuss about validation. So the validation block generally consists of statistical techniques. It's purely statistics which is involved there. So now can you see there is a method out here which involves some mathematics, mathematical steps. It will involve optimization, will involve OR and calculus, and validation block will involve statistics. Now the question is, do all algorithms have these three blocks? Now, this will depend on who is building the algorithm. There are a lot of computer science people who are from the background of computer science are heavily getting into this area. And some people are equating artificial intelligence with computer science. That is not correct. And there are many people who ask me, I don't have a computer science background, so can I get into this area? You can get into this area till the time I told you. I'm listing out the requirements. If you are ready to fulfill, learn those requirements, you can get into this area, right? So a computer scientist may not be good at mathematics. That's not absolutely correct. And only just knowing computer science doesn't ensure that your algorithms will start working, right? So please don't equate both of them. They are preferred because they are very natural at programming, and there is a lot of programming element here, right? That's the only thing. And or generally the business leaders don't know. So what happens is they hear from here and there, and they try to then do all this, right? So but there is nothing like where like computer scientists will not let's say cannot do well. Rather, like I've dealt with so many people, minority of them were only computer science, majority of them were non-computer scientists, and they are doing phenomenally well in this area. There's no doubt about it, right? So coming to the, do all the algorithms have three blocks? So now many of these algorithms are coming from people who have a computer science background. These computer science people are not very well versed with the area of statistics. So what happens is they remove this validation block. So generally when algorithms come from computer science kind of a background people, this block, the third block, is missing. It will only have two blocks. So there is no validation there. Okay, now that's a risky thing at times. I give you one example. If you want a very explicit example and want to know like what could be an example, like example clustering or neural networks. Neural networks are algorithms that are given by computer scientists. Clustering is an algorithm which is given by computer scientists. And computer scientists say that this validation, now they also have some, if you read a lot, there is a lot of debate. They say that this validation is not required because the way machine learning works, it doesn't require validation. I'm not getting into those details because that's not the right time. Time is ticking out. So, okay. So let me go further. But there is a debate there. Just keep that in mind. Okay. Now, what is artificial intelligence? Quickly. So AI, we can characterize a deep learning techniques, right? Because our brain has different layers. We learn deep, isn't it? So deep learning technique using artificial networks, and it's all depend on neural networks. Neural networks behave the way neural network is dependent on the neurons that we have in the body. So that's a biological kind of entity. So people have looked at biological phenomena and made this. So anything which is there to mimic brain and its component are related to artificial intelligence. Neural networks are based on neurons, which are related to brain, right? So these are artificial neural networks, and anything built on artificial neural networks would be directed toward deep learning or artificial intelligence, right? The theory and development of computer systems able to perform tasks normally requiring human intelligence. This is very, very important, right? Human intelligence, such as visual perception. We look at two Twins also, Ramu and Shamu, and we don't make any mistake out of them, right? Speech recognition, we recognize even if we don't see the face that somebody who's calling, if somebody known calling to us, we don't see the face, we know it. So can the machines do this job? Decision making, can the machines make decision like human being? Translation between languages, right? This is a very human thing. So when all these tasks are, and all these things are being done, this is not futuristic, this is already, the machines are already there. And all these tasks fall into the area of artificial intelligence. So when you have to do such thing, right, there is no data involved out here, right? There is a voice sample which is involved. Visual perception, the data is only an image, right? It's a picture, it's a video. YouTube, think of YouTube, they make recommendations to you. That means once you see a video, they know what kind of attributes, what kind of things you're looking at. They analyze the video, and next time when you go to YouTube, they give you a recommendation. So video recommendation, image recommendation, product recommendations, use. People also bought this book and all that stuff, right? So this is what artificial intelligence is, right? So you can see that this is about doing tasks which humans do. And how do they do it? They use something known as deep learning neural network. The different kind of deep learning neural networks that are used here, right? Not getting into details of all those because that's the session is not, the length of the session definitely cannot justify that. But I put something here you can see. So these are the traditional techniques. I'll call it the traditional machine learning, and these are the advanced technique or the modern machine learning, which you call as AI, right? So the things which are colored like this, they are all components of modern machine. I don't call it AI, I call it the modern machine learning. So the modern machine learning, or what you call as AI, uses these kind of techniques, and the normal or the older machine learning or the traditional machine learning uses all these techniques. So some names are written here, and you'll see dimensions. So you have to learn at least all this stuff. So when, and that's why I say that I was lucky. When I started, I had to only learn this much, right? This much only. And now for you, this is on top of everything. And this is a very difficult area, very difficult area. So for you, when you get inside, this whole lot of things have to be covered. So whatever course you join, or you do it on your own, or you do it through a mass online course, whatever you do, you have to cover all this, right? This has to be covered. Then only you can get into machine learning and AI, right? And plus on top of it, people will ask you, have you done any kind of a project, right? That's going to be there. So because we have only 1.5 hours, so I'm just touching upon things. I cannot go deep into everything. You can understand that, and that is because we don't have enough time to cover everything, right? So I'm just giving you a glimpse of it, and anything where you require any details or anything about it, we can later interact on that, right? Because I need to cover also. I mean, I cannot get into deep into one area because that we have to see the interest of everybody. Okay, now the question, artificial intelligence is great, it is doing so many things. Now the question is artificial intelligence a panacea, right? So I've taken some scripts from a report by McKinsey, a very recent report 6 months back. What it says, let's go through this. The greatest potential for AI to create value is in use cases in which more established analytical techniques such as regression classification techniques can already be used. So that means AI, there is one, if you cannot use the older techniques somewhere, chances are that AI may not be used. But if you have used older technique, chances are AI may give you better results. That's not a rule. Chances, I said, right? And because neural network techniques could provide higher performance or generate additional insights and applications, right? So all those things may happen. So it may generate additional insights, applications, and all those things, right? 69% cases, this is what happens, right? So where 69% of the cases, it's a choice. You want to use the older AI ML techniques or the newer age techniques. It's a choice, that's all. But if you do not know AI also, in 69% of the cases, you will be able to solve the problem. This is what I'm saying. Only in 16% cases where the older ML is not possible, only AI is possible. And I've told you those areas, right? Computer vision, speech, language generation. These three areas, the older ML techniques do not work. It's only AI which works. It's a pure AI dominated area. Now, if you have a question what to learn and how to get into it, the business problems purely may not be all AI problems. It may be a business which heavily requires the older machine learning techniques, isn't it? Because there is a lot of business data out there. Even if you don't know AI, if you know your older machine learning, rather they'll be better to use because they are less complicated and the visibility inside them is higher. In deep learning, it's a black box. Nobody has a visibility inside this. This is one of the biggest problem. Deep learning, nobody can translate into a human-like thing where like you can go and say that, okay, this is what is happening inside. Okay, so and all these always understand that ML and AI are just techniques, right? So if you want to use it in the area of finance, you want to use it in the area of logistics, you want to use it in the area of IoT, then you have to just, it's always what data you have and what technique you use. Machine learning and AI works on only two things. It does not matter what area is it, right? It only matters what data are you presenting. So you have to look at the data. I told you, you have to look at the data. Is it continuous? Is it structured? Is it a streaming data? If it is IoT, it would be a streaming data. So that means your infrastructure has to be of a different kind. So it can handle streaming data. So when you want to use it for IoT or big data, you need a different kind of infrastructure. And if you are not doing IoT or big data, then a simple infrastructure will do it. But the practice of AI and ML remains constant across any area, right? Across any area. The only thing is you need a support of a subject matter expert who can tell you what to do with your AI ML, what should be your objective, right? So some subject matter expert has to be there. So if you are trying to do a AI ML without having knowledge of a business area, it's not going to result into anything. It's not just firing codes. It's not about IoT. It's not about finance area. It's not that. You have to understand the problem, and that problem you as a data scientist know what data should be collected. So you'll collect the data that is required, use the algorithms that are there, and provide the results, and you'll translate the result into a business language in English so that the business can understand. This is what is there. Now what is data science? We are coming to data science. So data science, you will see a lot of Venn diagram. There is a battle out there for Venn diagram. Newer and newer Venn diagrams are coming. So you can see this data science. So data science, you can see it's about neurocomputing, pattern recognition, statistics, visualizations, databases. I told you you should know SQL. This is the reason. And then you say data mining, artificial intelligence. You can see, and this is the process. Domain knowledge. I told without domain knowledge, no data science can happen. If you're working in finance, lending, if you do not know lending, you cannot do any data science. Believe me, however good you are, right? So it's about communication. That's what I was telling you. The results have to be communicated in the language that business understands, not your alpha, beta, gamma. Nobody is interested in that. How you present them, that's about visualization, right? Are you inquisitive, right? So do you like to research? Problem solving, do you solve problems? Business analysis, right? So business, you can see domain knowledge, business strategy. So this portion is about business understanding only. So if you do not understand business, domain, whatever you call it, subject matter, three terms used for the same thing, it's very difficult to become a data scientist, right? Please always understand it. It's not always about firing codes. Okay, the other Venn diagram, some people say it this way, that it's a mix of social sciences, quantitative methods, and computer science. Some people put it this way. And this was the first Venn diagram, which was given by Drew Conway, right? He said, and this is the most correct, you say hacking skills means programming skills, programming languages, maths and statistical knowledge, and this is your subject matter expertise, business knowledge. And where these three meet, that is a data scientist. And if you have programming skills and you know maths and this thing, then you become a machine learning expert because your domain knowledge is missing. But if you have domain knowledge and maths and statistics, you can only do traditional research. And if you only know programming and you have only, let's say, subject this thing, then this is useless. This is of no use, right? So this Drew Conway's Venn diagram is the best one. I find the most simple and the most effective and the most correct out of, there are so many Venn diagrams that are available, right? So this summarizes what data science is. So it requires three things: programming skills, math, science, statistics. Substantive means your domain knowledge, finance knowledge or logistic, whatever area you're working, that one. Okay, so this is what data science is, mixture of three things. These are programming languages, like example R, this is the open source. Python, this is the most popular programming language. Python, very versatile, very easy to learn, so this is open source. SAS is a proprietary thing, you have to pay. And this is Alteryx, but this is a dashboard from Alteryx. Alteryx is also a paid programming language, so two are free and these are paid. SAS, you have to pay around 1 crore rupees to acquire it, and imagine the same thing. If you are good, you can do through Python, which is free. So it all depends, right? So there are platforms available for a fee, there are free things available. What is the current trend, if you ask me? Industries, this is leading. Most jobs are in this, maximum jobs. This is the job number 2, this is job number 3, and Alteryx is job number 4. Right, so availability of jobs. If you ask me which is the highest chances of getting a job, which programming language? Python and R. Python and R mixture is a deadly combination, there is no doubt about it. Okay, so that's what is there. So I've told you what have I covered till now. I've covered what all you require and why you require. I built a logic around it. I given you definitions. I've given you logic why you require it, right? I could have told this in a simple slide also. And the cloud is also coming in. So cloud, people are saying they're ready-made things. It might happen that people may not require any data scientists. At least the weak and new data scientists may not be required at all in next 5 years, right? Because this is what is happening. Azure, Microsoft, AWS, you know, right? IBM Watson, this is your Google Cloud. SAP is coming out with Leonardo. Salesforce has come out with Einstein. All of them are coming to self-service. So in analytics as self-service, even if you don't have data scientists, you can put your data on the cloud, automatic processes will happen there, and the results would be pushed to you. So the cloud is going to add one of the complexities. It's going to eat away into some jobs of machine learning itself, right? Or at least it will ease the pressure which is there on. There is a lot of gap between supply and demand of data scientists. At least it is going to ease out that now, right? But it's still, I mean, it has to prove. It's still not proven, but I think next 3 years, 4 years, this will do good. Companies are experimenting, but there is no company which is claiming 100% success about it. Bits and pieces, small operations, they are happening, but the complete analytics operation being moved into a cloud, that I will still heard, but companies are trying, lot of trials happening with all this stuff, right? So this is one of the dimensions. You'll have to keep a watch, you'll have to know about it, right? Very, very important. You have to know about at least one of it. Then you hear these terms, what is analytics, advanced analytics, modeling, are these different areas or whatever we've discussed. So these are just, when you say analytics, a person might mean just BI, or he may mean ML, or he may mean ML and AI. So you have to ask, right, what does analytics mean there? Or advanced analytics, when analytics generally means people working with Excel, so data analyst kind of a function, people also call the analytics. Advanced analytics, when they bring in at least R or Python for the first time, they say we are doing advanced analytics, and very simple kind of problem they are solving, but they call it advanced analytics. Modeling the same thing. So these terms are used interchangeably, right? So all these terms are interchangeable. You have to really ask somebody what does it mean. So people, they say all this, or when I go for consulting assignment, we do advanced analytics. Now I don't understand anything out of it. I have to ask very specifically, what does that mean? Advanced analytics. I mean, use machine learning, what kind of platform you use, what kind of a data you have, big data, small data, structured data, unstructured. I have to ask all the questions that I've shown you in the previous slides, right? Then only I understand as a data scientist, what is this company or this startup or whoever the person up to, okay? Now, these are use cases, probably, like example, alternate data scoring is one of the use cases. What is happening is, if the highest, let's say, funding is happening these days in fintechs, right? So what people are doing is, they are even giving loans to people who don't have a strong financial history. Banks will not give loans to these people. So what do these people do? Very surprising thing. They collect data from the telecom bills, from the utility bills, electricity bills. They take just their bank statements and make a profile of the customer, and just based on that, they give a loan to this, and they're successful. Lot of funding, huge funding is happening here. Lending Card, the previous company that I was working there, it got funded 800 crores is the funding that it got, because we mastered something known as alternate data scoring there. right? And it is doing fairly well. And I think the next round would be around 1,000 crores or something like this, right? Extracting this requires traditional machine learning here, no artificial intelligence. So machine learning techniques, probably I'll tell you the techniques also, classification and all those techniques are used. Then extracting information from document repository. So there are 10 years document customer, let's say related to customers, and we want to pull out the data and put it in a structured form. So information retrieval is done, and this information retrieval requires use of recurrent neural networks, right? Or something known as LSTM, right? Long-term, short-term memory network, neural network. That's what we are using to extract this information, right? And putting it here. Then summarizing text. If let's say there are 400 pages given to you, there is a book and you don't want to read it, or there is a film, 3 hour long film, you want it summarized, right? One is video summarization, the other is document summarization. So there are two ways of doing it. One is extractive and the other is abstractive. Extractive means it's machine like. So machine will see what are the terms which are frequently coming, this and that, and put it in that way. When you're reading it, it may not look like a human writing, right? It may look like a machine writing. There is some difference there. So that's known as extractive. But now the machines have reached at a stage where they can write like humans, right? You remember when you were kids, you were given a long let's say page or something, and you were asked to write a précis writing, right? Compress it and write like a human. So that's known as abstractive summarization. So abstractive summarization also now being done, and again deep learning neural networks, that is LSTM, biserial LSTMs are used for this. Now these may be terms which many of you may understand, many of you may not, but just telling you that this is the kind of use cases that I've been involved into. Fraud detection in finance. When somebody comes, is he a fraud or is he a genuine person? So that kind of a thing. So how do we detect fraud? That is also there, right? So all these are use cases which are based on machine learning, or which can only be solved based on machine learning. Either like this one is machine learning, this one is a pure machine learning thing, and these two can only be solved by using artificial intelligence or deep learning neural networks, right? So that's, but you require the use of something out there, otherwise you can't solve them. Okay, so so for learners, now let's come to the thing. So people who, some of you may be trying to get into this area, so what are the things that you need to keep in mind? One, always understand data science has a steep learning curve. It is very, very steep in the beginning. So you spend a lot of time and you learn very less, right? Don't get frightened and run away. The learning curve is going to not be so steep, right? It's going to mellow down after some time and it will start working in your favor. That means you will spend less time and you learn more. So that, but initially the data science thing, you know, there's so many components that you have to learn. So it's a really steep thing and you forget very quickly. So if you don't touch anything for a month, you'll forget. That's human, happens with everybody. Don't worry about it. But these are the phases in which you'll have to go. This area is very vast. I told you 16 years and I say I haven't learned 1%. You can understand the vastness of this area. To master it takes a lot of time. So you cannot have a 1-year agenda. You should have a 10-year, 15-year, 5-year kind of agenda. Then only you can be successful. It cannot be that I do a course in 3 months and there I see advertisements from courses, do a master's in this and that. They can help you to get a job because those jobs are available. But to really thrive and become good data scientist, I mean, that's the end of road. I mean, if you don't take a long program and you think that only, let's say, doing some courses or doing some mass online courses can help you, those are helpful, but then you need to bring in your own dedication to the table. You should have some skin in the game, right? Availability of MOOC, that is mass online classes, is very, very high, but those do not go very deep into the reasons why something is being done, the way it is being done. The practicality of use cases is not there. The practical use cases are not discussed the way it happens in the industry. The kind of cases that are discussed there and the way it happens in the industry, they are totally different. Nothing there. Why all this is happening is because very experienced industry professionals, they don't come as trainers, and people who train generally you'll see they will not have worked for a long time in the business. What those people are, those somehow they have mastered some slides and some data in some use cases, they keep on repeating it, but they don't have real business experience. And that is the reason that when people get trained here and they go to the business, they find that it's a bit different place, right? Because the entire life cycle has not been explained, the entire complexity has not been explained to them. And why is it not explained? Because the person himself hasn't seen it, the trainer himself hasn't seen it, right? These are the roles that you'll have to see. Data engineers are people who don't run algorithms, who only provide infrastructure. That means these are the people who will provide, who can do Hadoop, who knows Spark, that's all, right? So they'll build a Hadoop thing for you. They'll do MongoDB implementation. They are good at implementations, that's all. And some algorithms they may know, that's all, right? So they are the people who can provide infra. So see your interest, where does it lie? There, do you want to become a data engineer? So you build a pipeline for the data. Data engineers, as the name suggests, build a pipeline. And from this pipeline, ready data comes, which the data scientists grab and work. Data scientists are people, I've already explained what they do. They are responsible for making business thrive on data. Simply, that's it. The business should gain out of it. So they are people who are business facing. Then there are new roles which are coming up, like AI developers. AI developers are people who are not very experienced, but who are very good at coding. They don't know what algorithm to use, or if a difficult situation comes, they don't know what pre-processing to do, or should I use one more algorithm before using the main algorithm. So they're developers, somebody will give them directions, and these are young people, generally 2-3 kind of years of experience, and they can code very fast. They can code anything that you tell them. Then these are data AI architects, who are people who have a lot of experience in this area, may not be very good at coding, but they definitely know how a solution should be, what algorithm should be done, what should be done, right? So these are kind of roles which are coming, right, in here. Then for business leaders, people who are already into this business and all these things, so the challenges are, or the important things are identifying business-led use cases. The use case should not be a flimsy use case. Let's do this, right? Something which may not add value. So you have to really understand that it will do something to the business. Don't do a case just for the heck of doing it, right? Hiring the right talent, very difficult. I've seen people just copy resumes, right? A friend's resume is copied, and they have done some online course or something. So if as a hiring leader, if you are not thorough, they can fool you also, right? So you really need some good experience in hiring the right talent these days. Label data challenge, I've told you, the label data, the availability of label data is not there, so you can't use supervised learning. And majority of our good things happen through supervised learning only. 80% of the good things in the world happen through label data or the training data. That availability of training data is a big challenge. How do you generate it? How do you get it? Business leaders, that's one of the big problems. Infra decisions. How do you take an infra? Do you want to implement Hadoop? Do you want to go for GPUs? GPUs will provide you, generally when you are doing artificial intelligence, you require a very, very high computing power. That comes through GPUs. NVIDIA, you can go to GPU, NVIDIA and read about them, right? Graphical processors, right? How do you understand the ROI of AI, and how do you explain, how do you take a meaning of AI, right? There are different meanings that float around in a company for AI, right? That's why I put those definitions there. They adapt some definition, and everybody talks about AI in the same way. In a large organization, if you go, you will see 10 people will tell you different definitions of AI. That's something very, very sad. We should have a common understanding, right? Uh, Potential areas where fail areas where like the business feels very, very difficult, or not able to come up, and all those, that executives don't have a clear vision, right? So what they think is that one use case has come, so they decide, let's have a AI ML team, right? And then there is a problem. Beyond two use cases, you don't find other use cases, and then suddenly you see what should the team do, or they do useless use cases. So that should be a clear vision. What do they want to do? Uh, the value of the use cases should be very, very clear. What's happening out there. Uh, the then instead, I said they don't start with just few use cases. Have a holistic analytics strategy. What are you going to do? How are you going to develop over a period of time? What all problems are you going to solve? Do you have data? If you don't have data, how are you going to generate? Where are you going to keep your data? What kind of infrastructure will you reach? So these are the typical questions and answers that are faced by business leaders, right? The role of analytics is very poorly defined. I've heard people saying, I have tons of data. I don't know where did you take it and actually weighed it, right? So what kind of a scale you use for measuring how many tons? But And this is a typical problem in my company also, which is a very old company, but there are some business leaders who come to me and say, I have tons of data. But actually, when I start using that data, when I start looking at that data, I find it's not a useful data. It cannot solve the business problem that they are asking. So this is a tragedy. What is happening is that people started collecting data, and at that point of a time they did not knew that AI ML kind of a function will come, so they were collecting data which they thought was correct. Then suddenly this function, this area of AI ML comes, and if you look at this data from the lenses of AI and ML, you suddenly find out that this data is not appropriate to solve the problem that is being discussed with you, right? So one of the important jobs of a data scientist is to ensure that there is correct data and enough data, right? The other extreme is people don't have data and they are building huge plans for AI and ML. The data is very, very small. If the data is small, I told you it's risky. If you are very, very experienced, then only try to do AI ML on small data. That requires a lot of experience, right? Just don't try to do AI ML because you know some programming. Can be very risky. Chances are that the business may go for a toss if you are doing AI ML on a small data, not an appropriate sample and all those things, right? So a data scientist has to know, or has, before starting a use case, this is one of his role. He has to look at data. He has to ascertain that it is the correct data, it is in the right shape, the quality of the data is good, and it is appropriate for solving the business problem at hand. So it can solve the business problem that the business want to solve. Otherwise, it's a very risky take, isn't it? So this is what in the end, like I like to show you the talent requirement. If you look at it, there are so many talent requirement. You need something known as data architect, data engineers. These are technology skill, data scientists, statistical models, workflow integrators, visualization experts, right? Analytics translators who can actually look at the analytics output and explain it to the business. Then they're delivery managers. So these are the different kind of roles that you'll see. So this summarizes the different kind of roles that are there, because there are so many roles. So you can understand, and this is relevant for business leaders. Hiring becomes a challenge. So how do you hire for these different things, right? If you hire the same people for all of these kind of, let's say, roles, may not be a good strategy. So this is where you have to understand people who apply in detail, and you have to understand what role this person can do. And you can see there are a lot of overlaps, right? There are a lot of overlaps. Nothing is pure out here. So a data architect will ensure quality, consistency, and data flow, but he'll know some amount of, he'll know some tools that data engineers use and some tools that data scientists use, right? He may not be expert at it, but definitely knows about it, right? So this is where the situation now stands, okay? And these are the different kind of roles, and those are coming. So I think this is what I wanted to, let me now stop. And these are like the lot of good work is happening in this area. India, if you look at it, then the maximum funding is happening in the area of fintech. Uh, in US 10 years back, the maximum funding was happening in the area of fintechs. Now it is happening in the area of AI/ML. So you can understand India also what is going to happen. And this is already started to happen. So a lot of funding, lot of startups will come in the area of AI/ML. I think next 5 years, and huge funding will go into it. If you want to look at some good, let's say, startups, these startups are good according to me. You may like them or you may not like them, but Gamelon, Narrative Science, this is NLG, stands for Natural Language Generation. So what is natural language generation? A superb kind of area is based on GAN something, right? GAN is a flavor of deep neural networks. So what it does is, let's say somebody was speaking on a phone, and suddenly what happens? There is bad, let's say, network, and the voice vanishes. And after 2 minutes, the voice comes again. So there is a patch which is missing. So if you know the NLG technique, it can actually generate what would have the person said. It can predict what the person would have said between these two spaces. So it can generate natural language, right? So it's a powerful thing you can know. Hiring and recruitment is being done through AI/ML. You can see visual product recognition. Product recognition is being, so this relates to, this will relate to your retail area. This is the HR area. This is a general area, can be applied anywhere, and these are natural language bots. So this can be used for answering customers, external customers or internal customers. The chatbots which were built till now did not have a big AI ML component into it, but now the chatbots which are coming, they have a huge AI ML component into that, and that is why they'll be more accurate and better, right? So a lot of good things happening out there, a lot of startups will come, a lot of funding will happen in this area. So a lot of exciting thing out there for all of you, but there is a challenge. This is a vast area, and you need to pick up multiple skills to become a data scientist, as you would have seen, right? So with this, I like to summarize my this thing, and now I'll throw it open to any question answers that you have. So I like to answer your questions right now. So I'll pick up whatever questions come in that order, and I like to answer it, right? So I don't know how many like questions I can answer, but I'll try to answer as many as possible, because I'll have to make a hard stop at one, right? So some of you are asking any online website. So just go to Google and just type machine learning course by Andrew Ng. That could be the best course that you can start with, right? So that's a very good course that you can start with. And if you go there, like you'll find there are a lot. So go to edX and all those places. You'll find Coursera, edX. These are the places where you'll find a lot of online resources which are available. Okay, so the second question is, as a novice to get entry in data science field, which language and which algorithm I should run as per job perspective, and where can I learn? So when you are entering, this is a good question. So try to learn Python from the programming language perspective, and algorithms, I think you'll have to learn 8-10 algorithms minimum. And now it depends on where you want to learn, right? So like Collabora also runs a course, so you can learn it there, which is instructor led online course. So if you are working and if you want to learn it on weekends, then Collabora and those kind of things are there. Then you have mass online classes where you don't require any new human intervention. You have to look at videos and you'll have to learn there, right? So those are the options that you have. It depends on what kind of time, what kind of commitment that you want to know. Okay, so Krishnan is asking, glad to know you and thanks for this brief. While explaining predictive analytics, you indicated that this method is not suitable when the output is to be predicted is not dependent on past data. Give some example of situation and algorithm used to solve them. Okay, so they are not much like example. If you have to predict earthquakes, right? Earthquakes, you don't have any past data. It doesn't work. The past doesn't follow the future. So there are no algorithms as such which are available, but people claim that they have come out with some kind of algorithms. I'm not sure how effective they are or how good they are, right? So probably you'll have to go and have a look at all those algorithms. Right? Machine learning course, these are Coursera, edX, edX, Coursera, right? So course, just put a RA in the end. That's the. How many days of learning needed for Python for non-technical person? I mean, see, learning is a very human kind of a thing. It varies from person to person. So we don't have like formulas where we can say that, okay, that is enough. But generally, majority what I've seen is, even if you are a non-technical person, I'll keep that in mind, Ananta, that it might require around 3 months, right? 3 months should be enough. And I'm assuming that you're spending at least 2 to 3 hours a day, right? So if you do that, 3 months should be enough. How can we compare the 3-tier architecture with data science? I don't understand what is the 3-tier architecture and the data science. I mean, I haven't understood it. I'm sorry, right? So you'll have to explain or write a little more about it. How do a project in AI and ML for training purpose to get hands-on? Nobody will share actual data, I tell you. No business is going to do that. It's only that some of these people, like we run a course, there what we do is, we like whatever course Collabora runs or whatever portion I take in that, at times I take a major portion out there. So what I do is I bring the data and I anonymize it. And it's a real data only, but I anonymize it. So even if you take it to somewhere, you cannot relate it to where it is. So getting hands on a, but there are some websites if you want, right? You can just Nitesh, what you can do is you can just type machine learning repository, and this is your UCLA, not UCLA, but University of California, Irvine campus. Just type in Google and you will get access to around 200 data sets. R also has 250 inbuilt data sets for practicing and learning. Okay, so that's so you can just type, all of you, if you want, if you have your systems in front, you can just type machine learning repository from University of California, Irvine, IRWINE, Irvine campus, right? And you will get a list of very good curated 200 data sets, but they are not business data sets, they are research data sets. Getting access to business data sets is very, very difficult. That only people who are training or companies, if, or Kaggle is one more thing. Yeah, Kaggle, you will get a lot of business data, very large data set. Kaggle, Kaggle.com. So type Kaggle.com and you can get access to as much business data, and that's big real data. So companies actually keep that data there and they announce competitions. So that means if you solve that competition, they also announce prize money out there, right? So you can go to kaggle.com and work there. That's a fantastic source. I've told you University of California, Irvine campus, and you can in general also search. But these two, let's say, sources are a very good source to start with, right? If you finish this, then think of going somewhere else. Okay, like after 10 years experience in other domain, is it right to enter AI or ML? Jami, I'll just say that I already had 10 years of experience when I entered this area, right? So if that answers your question, so there is no right age or wrong age. It's there is no I mean, you don't require any background, foreground into it. What you require is the intention. So I'll say machine, I'll just define it this way. Machine learning, artificial intelligence are, let's say, these are developed by human beings and they are developed for human beings. Until the time you say that I'm a human being, it's meant for you, right? So you are 10 years or 20 years, that will not matter. What will matter is your intention and passion in this area, right? Can a .NET developer become AI expert? So a similar question by Shiva Shankar. It's always right. If you think that you can, you are excited about solving business problems, you are excited in this knowledge area, you are willing to pick up all this knowledge area. So it doesn't matter you are .NET or without any net, right? So that's what I've been telling, right? So backgrounds and foregrounds are not important. What is important is two things: your intention, your passion, and are you ready to commit to the knowledge areas that are required. If your answer to these three things is yes, please move in, don't worry about it, right? I told you initially there would be a struggling phase because the learning curve is steep, that I agree, but slowly it will start working in your favor, right? So you have to struggling initially and then you become a master. It's all. What are decision factors whether to use traditional advanced techniques? I told you, like, simple, like whenever you are dealing with human like things, like example, recognizing pictures, recognizing videos, dealing with natural language, translation, anything to do with language, it is absolutely a artificial intelligence area. In the other areas, you always start with a smaller hammer. That means try, because the traditional machine learnings require less data and the artificial intelligence requires humongous data. And if your data is smaller, you will always start working with the traditional machine learning, right? If you have large data, then it's your choice. You can start with machine learning or you can start with artificial intelligence. So this is one way of deciding whether to use the traditional or the advanced technique, right, Abhilash? Okay, so in HVAC and building automation, where AML, is it already in use? Yes, it is already using. So if you type building automation and HVAC heavily, Mahesh, this area is being used. India, I don't know, but US and Europe, this is being heavily used. Mahesh, in general, I can challenge you to bring any area you may know and tell me that is AI ML being used there. I can guarantee you AI ML would be used there. So the answer to your question, yes, it is being used. So if you are from this area, I'll say start looking into it. India requires these kind of people like you who can work in building automation, HVAC, who are subject matter experts, right, and are ready to look at AI and ML. That's a very good combination, I'll say, very useful combination. since we are new to data science field where we don't have real work experience, will companies prefer candidate like us? See, simple people, there is a requirement of people, so a lot of freshers are being absorbed, there is no doubt about it, Sridhar. But you need to work on some dummy projects at least, right, where at least you know how the projects are handled. So if you say that I don't know programming, I don't know machine learning, I haven't done any project, and I want to get into some company that will train me because I have intention, that is impossible, right? So you need to be good at programming skills. At least this is the bare minimum. People will not take you if you are not good at programming. You need to have dealt with some data. You need to have solved some use cases. Then only people will take you. So there is a space for freshers, but trained freshers, right? That's what I'll say. Absolute freshers, no chance. How to gain some project experience after edX and Coursera? That is very difficult. You will have to talk to somebody known, and if you can get access to the data. But this is, Ajinkya, this is a very difficult area. That experience is a very difficult thing. That's why there are many people who do not go for mass online courses. So what people do is initially they go for instructor-led courses because then it becomes their responsibility to bring projects, right? So they bring projects, and later on when you are absorbed, then you start learning through, because then you are inside a company and you want to enhance your let's say knowledge and all those things. Then people do lot of mass online courses, or till today, if there is a new area which comes, I'll do it on mass online course, right? So this is the strategy that people use. But if you do something on edX and Coursera, Coursera, your spelling should be Coursera, right? So if you do it on I'm sorry, if you do it on Coursera, then the project thing is definitely out. You'll have to really make your personal efforts to get some project somewhere. So that is one is there. My contact number, okay, I'll put it on the slide at the end of it, right? Not a problem. When we say that pin code is a nominal data, which seems to be a number, but we actually not. What does that mean? So a very simple thing. I mean, let's say there is a pin code which is 1002 and the other pin code is 2004. Can I say this pin code is 2 times of that? Both are numbers, right? So this is what I mean. Though they are numbers, but, or can I subtract 2002 and 1001 and say this is the difference of the pin codes? So both the things are not applicable. We cannot do any mathematical operation. This is what I meant when I said that, right? So no mathematical operation can be done. Plus, minus, division, multiplication, all are invalid because they lead to nothing. Okay, so is there any online simulator for trying out ML techniques? Big step may be required. No, there are no online simulators. I mean, the world hasn't reached to this place still, but you can see some startups are giving you their tools to try for some free, right? So like example, Alteryx, you can download some kind of a version, you can try to work on that and all those things. And R and Python do not require any kind of a thing, right? They are free, you can download them, you can try to run them and see. But if you are saying that if I want to solve some business problem through a simulator, that's not possible also, because you'll have to first learn programming, then you'll have to learn machine learning, then only you can do that, right? So I mean, if you say that even before I try to learn machine learning there is a simulation possible, practically it's not possible, so it does not exist, right? If a person has more than 8 years experience, business is a good idea. Yeah, I mean, I told you, age, number of years of experience, these do not matter, right? What is the best way to transit from to machine learning? Siddhant is very simple, but you'll have to like get trained into that. You'll have to learn all that, and that's the only way of doing it, right? But if you are experienced, then at times you have this advantage. You can show some of the past experience as working in analytics or something, right? So if you already have some experience and if you are intelligent enough, you know what I'm saying is you can actually say that, okay, I was already doing some machine learning. So you can actually make it count like a machine learning experience, right? If you are intelligent enough, that's what I'm saying. Prerequisite for ML/AI: intention, commitment, not being afraid of mathematics. That's it, right? So that's the prerequisite. Jay. You said optimization in algorithm need knowledge of maths, and how much deep knowledge of maths? See, it all depends. Optimization algorithms, you are not going to design Prachi, you are going to use everything which is already, let's say, there. So when you just want to understand, then you don't require a very deep knowledge. But if you want to design it yourself, then the level requirement uh, of knowledge is very different. So I'll say just knowing that what a gradient descent is solves your purpose. You may not know the actual steps of solving a gradient descent problem, but even if you know what a gradient descent problem is, that's good enough, right? So hi Manju, you have said hi, so I said hi. Okay. Mubashir says, is big data analytics and AI same? No. Big data analytics, though, see what I'm saying is, Mubashir, this is what I said when I presented, that there are a lot of overlapping in these terms, right? So you have to understand what the person means. So when somebody says big data, he may be just pointing to the data engineering part of it, right? He may be meaning the data engineering part of it, that's all. And AI will mean solving some problem. So that's why I'm saying these terms are used and they're very confusing. Let's understand that. So I mean, you have to really ask a second question and understand what does that mean, right? But ideally, big data analytics would be a part of AI. This is what I'll say. Okay, it's a sub part of AI. This is what I'll say. So if you want to do AI, big data analytics is a must out there, right? So it's a sub portion of that. When there is so many other algorithm technique programming, why only AI today? Why AI today? Because see, AI, I told you some of these areas you cannot like solve it through other things. Like example, understanding language, right? Programming languages cannot, programming language is just a medium of communication. They don't have any intelligence. So the role of programming language is nothing, it's just a medium, that's all, right? Because a child also knows how to speak, isn't it? But can he communicate? That's a question. So that's what the programming languages are. They are as good as the user. Now coming to algorithmic techniques, why we need algorithm techniques is understand there are many business problems which are new to the world. Did the internet exist 10 years back the way it is existing today, or 15 years back? Now with the internet and the social media coming up, there are a lot of new avenues which are coming. There are a lot of new opportunities which are coming, a lot of new challenges which are coming, isn't it? So that means we need to have new algorithms, we need to have new system to accommodate the new type of data, new methods of communication and all those things. So that is why newer and newer things will keep on coming. And anything which is coming new is now being classified as AI, right? So that's where it stands. So algorithms will every day, if you look at Reed's research journal, every day at least 10-20 new algorithms come. The issue is that all of them don't become popular. Only handful of them are used by the world, right? The rest of them go in a cold storage or in the research papers, that's all. But how many algorithms would be existing out there? Probably millions, higher millions. Now higher millions nobody will learn. So you learn 10-20 algorithms which you think are useful, or anybody who's guiding you out of his experience knows they are useful, and that's how you work. And if you require one or two additional, you pick it up, right? You need to learn not 8-10 algorithms, I say 8-10 classification algorithms, right? So Pramod, I didn't say 8-10 algorithms in total. I said 8-10 classification algorithm under the heading of classification. If you, there are 90 algorithms just under classification, 90 popular algorithms. Out of that, if we are starting, we should at least know 7-8 algorithms to start with. This is what I was saying, because we cannot learn 90 in few months time. That will take many years to learn. So under classification, we should learn at least 7-8 algorithms. So you divide your things into different areas, and under that you start learning. This is what I meant to say. In the future, okay, if like depends, like Krishnan, if there is a requirement and if you shoot it to, let's say, Collabora, we can have it. I'll not mind it, right? We can have a detailed session also. So you can just say, this is what our expectation is. So I'll collect all those expectations and we'll write a mail to you saying that, okay, we are organizing a session again where we'll deal with things in detail, right? This was supposed to be just 50,000 view, right? Oh, that's great, Ramaya, right? Ramya, sorry, I'm sorry. It is good option for starting my career as a fresher. Sai, I think I've explained it many times. It's a wonderful area. It's a God-given area. That's all, right? That's all I can say. Not because I'm working in it, but actually it is. I may become a fisherman next year, but even when I'm like catching fishes, and if you come to my boat and ask me how's that AI ML area, I'll say it's a wonderful area, right? So do you think a normal programming infra engineer can make better? It all depends. I said, yes, he can. My answer is yes. If you are ready to learn, it's yes. I mean, see, ML Azure, like, let me pick up this example, Raghav. You have given an example of Azure ML. Azure ML is a new technique. So where will you get 10 years experience people in this? Tell me the logic. So whoever is working is a new person only. And when this area is expanding fast, newer and newer things are coming, then what is going to happen? You'll not, there are people who ask me, do you have 15 years of experience in AI? I tell them, are you stupid, gone mad? Was this area existing 15 years back? And if somebody is telling you that he has 15 years of experiences in AI, he should be a cheat, isn't it? I have only 5 years of experience because this area in India is only 5 years experience. Now, if you say you have only 5 years of experience in AI, that's not much experience. It is that way because it's a new area. So what I'm trying to say is there are new and new areas coming. So this idea of experience, though it matters, but you cannot take it to heart and say that this is the only thing which matters, right? So understand this also. This is one more dimension. Good full-time PG programs. There are PG programs, Amit, right? Now almost every IIT is running a full-time PG program. So you can, triple ITs are running it, ISB is running it, all IITs are running it. So it all depends where you want to do it, right? So go through it where you get admission, where you like the fees and all those things, and you can go there. So there are a lot of programs, lot of them. And how robotics field can be correlated. Robotics is dependent on AI these days, right? So the robots which are now handling humans, they need to understand emotions, they need to understand everything in detail. So it's, other than the hardware, everything is AI inside it, Arpit. Okay. And do you have algorithms in AI ML to make demand forecast? Yes, yes. Seema, that's a very common area, and that's a huge undercase. That lot of use cases. I mean, tons of them existing out there, right? Very common use case. Yes, Ananta, this is the right thing. http archive.ics.uci.edu ML. Yeah, that's the right place. Yes. Oh, okay, okay. So like my this thing is I do not have full knowledge of this 3-tier architecture, and I'm sure this has nothing to do with the data science thing, right? Security and all those things are important areas. They matter, but it has nothing to do with data science as such, right? Any specific course after NG course? I think what I'll say is that first go through that basic course. It's not a course that you can finish in few days. It will take weeks. After that, decide what to do. Till that time, you'll come across many courses, and then depending on your, I'll say, appetite, your learning, and all those things, you can decide what to do, right? I'm a data engineer, Hadoop, I know Python, learning MG, NG, other books. That's very good, Muthu. Data science, yeah, so good. So you're already like, you know, the programming part of it. So start learning algorithms, move to Skyline, is this Scikit and all those things. Yeah, so that's easy, I think. Yeah, changing from data engineer to data science, I don't think there should be any challenge. The only challenge is you'll have to learn some ML thing. You'll have to do some hands-on use cases, and you can make this move. Not a problem, right? So Marcel has a question. How can ML learning be integrated in Excel? Excel actually comes with its own AI, this thing, Marcel, right? So Excel also doesn't want to be left behind. So what it has done is it has also come out with an ML package. You can integrate it with Excel, and you can work on all the algorithms actually there. And at times I really like working there, right? So that's a good thing. Marcel, by chance, like, are you from India or some other country? Yeah, so certifications are important. That is there, all those things. I don't know how many more. So I'll pick up the last questions, right? So this is from Sumit. He says emotions, perceptions, or recognition kind of thing come under AI. What language use behind these? So there is a programming language which is a package in Python which is known as Keras, right? And the techniques are known as deep learning networks, right? Deep neural networks. That is what is used, right? So there is no separate language, but there's a package, right? There's a package which is used, and there is the architecture which is used. Two things there. So architecture is deep neural networks, and the package that is used is known as Keras, right? So all these courses are good, Amit, right? It all depends on, look at the curriculum. I mean, look at the curriculum very, very closely, right? Christu Janti College, that's Bangalore, Marcel, and I live near Christu Janti College. You are my neighbor. Great. Okay. So I have a neighbor also who joined here. That is Marcel. So, okay. So I think now I may not have answered all of your questions. Thank you all for participating. Any questions that you think I haven't answered are important, please shoot them to Collabora. You may not get the answer the next day, but I'll definitely try to answer it over the weekend, right? So I'll not leave your questions unanswered. Anything that you think that that needs to be answered, please send it to Collabora and I'll see that it is answered. This is one. I'll have to make a hard stop because I have other meeting commitments. I'm sorry for that. Otherwise, I would have extended the session. But the problem is I have other meetings, right? So when you have other meetings, we can't do that, right? So thank you all for like participating and asking those questions. And I'll give my number if you want, right? So I'll write it here instead of Q&A. My number would be, if you want to call out, right? So this is my number. You can note it down if you want to call me, but please call me after 7:30, right? And daytime I will not be answering them because I'm in meetings always, so I don't answer them in the daytime. I only answer my phones only after 7:30. By chance, if I answer it, that is there, but I will generally answer them after that, right? Okay, so thank you all. And I hope this session was useful to all of you, if not 100% to some this thing. And this is my number, and if you want to reach out, you can always reach out to me. Okay, so thank you once again, and I'm closing the session. Thank you, bye, and best of luck.